Preparing to live stream the meeting. Setting up your meeting
Hey,
on YouTube. Oh, done. I always wait for it to pop on though. And then echo at me.
I was gonna say, cue the echo.
Yo! Okay. Now I can shut this and we can talk. All right. Boop. Okay, let me turn
sounds
volume back
good.
up. Okay. Yay. All right. I don't have the chat. If
Hello.
anybody's out there, I don't have the chat up yet. Let me see. Let me
I
get
got
it.
the chat.
Looks like one waiting.
Let's see what we have. Well,
Hi, Jesse.
I always give it a minute and we'll give her a second, see if anybody else wants to join our little discussion today.
Going back to the basics.
Going back to the basics
I think it's time we had a reset.
as a sort of was a oh, there we go. Hello, Heidi and Steve. We got a couple people here. So we're going back to the basics today. Um, kind of a, we always take suggestions, and this was kind of a suggestion because there was some confusion going around with filaments and flares and CMEs and oh my, that's a lot of things. And so we figured we'd reset, now that we're seeing a lot of filaments and a lot of filaments.
Lots.
And
Lots of activity in general.
and the thing about filaments is they don't trigger, like we get alerts. We get alerts for flares, we get alerts for, radio blackouts and things like that. But filaments launch and they can be quite stealthy and you don't really, unless you're watching, you don't kind of know they're there. And they usually have, well, yeah, they have CMEs with them. So we do care about them. Um, and depending on where it's launched and which configuration it could be, like April 23rd, 23, we had that was a G4 event and it was a filament eruption, but it was textbook, it was center disk and it was the flux row configuration you absolutely want. And it was just, it was, yeah. So we don't get that very often,
Everything.
but it was everything you wanted with a filament eruption. So therefore, we're going to do that. And I guess we'll talk a little bit about, current events because we did have like a transient type structure come through and possibly a sector boundary crossing that's driving some activity. But we also have a giant moon. So it
Giant bright.
hasn't been super exciting because of the big old moon. So therefore, yeah. All right, so I will hand it over. I always like to, oh, actually, let me give you guys sharing power because I always like to let Tanya or somebody drive this because I mess it up all the time.
Oh, we're unplugged. We have to
Yeah.
mess something up.
I'll
That is a rule. I'm pretty sure that's an actual
I
rule.
start talking about the slides that nobody can see.
Well, I can drive. I
Yeah,
got
All
it
right.
running.
I gave you sharing power, so Sun Fun 101. Actually,
Sun Fun
the
101.
whole dang title rhymes, which is great.
Yeah, we'll just go back to that because it's fun to say Sun Fun 101. Tanya, I'm
Sun
going to
Fun
assume
101.
you did not do that on purpose, but
Sun
it's pretty
Fun
funny.
101. All right, enough of that. We'll go on to the slide here.
So
So
we're
yeah,
gonna, yeah, we can start with just an overview of what we're gonna talk about. We're gonna talk about literally things that you can
Overview.
see on the sun. So it does not include solar wind data. That would be a separate talk almost, but this is what you can observe on a disk, well, with the help of quite a few satellites and sometimes ground observations from solar telescopes. But for the features, we've got active regions, filaments, and prominences. They're essentially the same thing, it's just depending on where they are, we call them by different name. Coronal holes, which rule the show at this point because we are in the descending phase of the solar cycle. And as far as events, we got solar flares and we got CMEs, which we do care about quite a bit. So let's dive in.
yeah.
So, active regions. Christian, do you want to take this one?
On it. And I like the the kind of blank magnetogram look on it because there's what two spots I see. Oh, that's today. Or oh,
It
that's
is
sad.
today.
That's okay. I got a video for other
Today.
ones.
It's going to the overview of current
I was
events
like,
and
why did
needs
you
on the
pick one
sun.
from solar minimum? Oh,
Because yeah, I decided to just update. We're doing current events and a review of solar features at the same time. So we'll talk about it.
well, this is one example in that case. So we've got a photo of a magnetogram. This looks at the radial component either coming out of or going into the sun of the magnetic strength of the surface. We know that sunspots are just dark areas. If you're just looking at the sun through, let's say, a solar telescope or through those cool glasses you can get for eclipses, it's just dark spots on the sun. They are dark because they're much cooler than the rest of the sun because their convection has been hindered from the strong magnetic field, keeping it from doing that. So this view over here that from SDO lets us see that magnetic field strength. Dark red and dark blue are the stronger positive and negative polarities. And then you've got yellow and green, which are just patches of it. And then gray is just neutral. But the point is, they made things. They can flare. They can have filaments with them that sometimes erupt. They can CME launch, hopefully, sometimes. I don't feel like we get much of that towards us anymore. And you can see them via, well, again, you got solar telescopes on the ground if you need that. So any solar telescope with an H alpha filter block or with just a glass shield on it, you can actually see these in telescopes. If you need to go spacecraft, you've got SDO. It's the HMI instrument. This is the, again, magnetogram. There's an intensitygram one as well that lets you see the actual light curve. And then there's the solar synoptic maps that people draw from SWPC.
Yep.
I
And
decided to kind of connect this with the May events of last year, since we are a year from the Gannon storm now. So this was the region that gave birth to all of those flares.
look
This
at
is,
that.
to be fair, I don't know how short,
It
a
just,
week. I think this is a week of period just sped up, and we can see how extreme this gets. But this was the region that caused all the issues. Why isn't there a repeating function? That would be awesome. Yeah,
yeah,
oh well.
that
I wanted to
was,
kind of more so just let it play back and forth so you can see how they change. This is just they move through like they're little lily pads on a lake or something. But the
and
point
it,
is that's what they look like in white light.
and it came out, it came in angry. Like it was just like,
It went from
oh,
almost nothing. What I should have done, I didn't want to do the whole thing, but I was going to do from beginning to end of this sunspot. But the point is just to show what they look like, so I didn't really
yeah.
want to be that dramatic and have the whole thing. We can do like an actual Gannon storm coverage sometime. But the point is, this is a sunspot. There are a couple other features that we look for, though. Uh-oh.
No, now you're stuck.
There. Yeah, my keyboard part stopped working. There are also other features on the sun called filaments. It's technically prominences as well when they're on the edge. So actually, this is a pretty good solar disk image. You've got these black squiggly lines, and then you've got the giant red arcs on the sides. These are, I'm going to call them coils of plasma that is a bit cooler. That's why they're a bit dark against the surface, but they're anchored at each end to the surface. So they're just giant arcs kind of dangling and doing their own thing, but they move and dance a lot as well, especially when they're getting ready to erupt. If you're looking for these, you can look in a dedicated H alpha telescope, which are really fun to look at because actually seeing them with your eyes compared to seeing them in SDO is a quite different experience. But if you need to, you can check SDO. The 304 wavelengths are good, which is the one we're looking at now. Really, any of the Corona ones are pretty good too because they also show the darkness of the actual filaments. SUVI also has the same type of wavelengths, so you've got two spacecraft there, and then the synoptic maps are also used when they draw them on. But to the movement, and I like this example. I think I found this one from May of last year, but several days before the event. So it's like the first or second. This is a filament that just got done erupting. And actually, I'm gonna pause that and make sure it's on full quality because it really does matter. There we go.
It's a pretty one.
But it shows the dancing how they move and twist and turn, but it also shows how a prominence and a filament are the same thing. This is basically, you're getting the same exact view just from different angles of this arc of plasma that's coming down. But look at the movement on this. They are pretty. They do dance a lot as well when you get them at least ready to erupt, or at least hopefully ready to erupt towards us. I can do the all four, or do somebody else want to take either two? We don't really have a ton of material to go through.
Sure.
I can
I'll
say
keep going.
coronal holes. Yeah.
Yeah, do some coronal holes.
I think we went over coronal holes previously, but they
Mhm.
are areas of open magnetic field lines. So this is where magnetic fields don't loop back to the sun. They're just going into space, into all the way into outer heliosphere. They do close on something eventually, but most importantly, they are sources of fast solar wind because it's easier for solar wind to escape along the open field lines. And we do get the co-rotating regions. So that's the CIR. If we haven't seen that coronal hole before, that's the stream interaction region. So basically, slow solar wind, fast solar wind that's catching up, and you get an area of compression. That compresses magnetic field, and when magnetic field is compressed, it gets stronger. So we get higher BT, and that can result in some nice storming. And we do care because they do produce nice auroras, particularly when that magnetic field is compressed. So it's part of both slow compressed solar wind, slow and compressed fast solar wind that produce it. Once you kind of get into the fast solar wind itself, when magnetic field strength drops, you don't get the same level of storming anymore. So you kind of want to catch the beginning of it, although it still can storm mostly at kind of higher latitudes. So for us, once you're into good old-fashioned fast solar wind, it just doesn't get that spectacular
Show's pretty much
anymore.
over. Yeah.
Yeah, unfortunately. And we are definitely in coronal hole season at this point. So there are coronal holes. They do appear dark in certain wavelengths. So you better see them with either SUVI or with SDO. And they appear as those dark patches. So they're not holes in the sun. They're just open areas. Think about it as sort of a window through which the really fast wind blows. And SWIPC marks them with both location and polarity, so you can see which one is coming. You want them located as close to the equator as possible. They're most impactful when they're fairly sort of around the equator, solar equator, and there is one that's sitting right there. It is small.
Tiny one.
Bigger ones do produce slightly better shows, but don't write this one off. It still might do something. Because it takes about 2 or 3 days for the solar wind to reach us, when that coronal hole is sitting near center disk, we're not feeling it. But once it moves, that solar wind finally catches up to us and reaches us. That's why it looks like the coronal hole has to be about 2/3 away from the center by the time we start to see the impact of it. It's not because it's blowing at the angle, it just means that it takes time to reach the us over that distance. So that's where we at with coronal holes. And oh,
Quick
there's a
video on that
paper.
one just to see it
Uh,
active. This is
oh, that's a
going
big one.
backwards
Yeah,
to
that's a
20.
good
This is the
one.
decline of cycle 24 for this one. So this is what they can look like. And this is even a bigger one. It's just a more stretched equator word one. But I like how you just get to see some of the UV points come in and out of it, but for the most part, it's just black.
But in case you were wondering, like this, that's why when in like Space Weather Live will send out um alerts when it says trans-equatorial coronal hole, because like Tanya was saying, the ones that are closer to the equator are the ones that we really are more interested in. So figure I'd add that.
Ray, just to explain that comment too, since I see it anyway. So, of course, the concept of closed magnetic fields, you've got plasma that's going to go from the positive end in a loop towards the negative end back into the sun. Open field lines are out technically towards infinity. So you have just plasma that gets out of the sun and it just keeps going.
That's why it's
So
fast.
open is, it does close if you go several AU out, but the idea is when it comes to us, it's just coming straight out of the sun. That's all.
Okay.
Oh, I always have to hit the button for next slide. Next slide.
Next,
There we go.
solar flares.
Your
So
turn.
yeah, so solar flares, these are reconnections within active regions. So why, I mean, why we care about these so much is they're highly energetic. And because of that, sometimes they produce CMEs, sometimes they don't. But when they do produce a CME, they tend to be quite energetic as like comparative to filament eruptions, which are more I mean, they're just,
Almost quiet, really.
yeah, they're like a little wisp. They kind of dance off the sun and come our way. Whereas flares are like in your face.
Accurate.
So that's why we tend to care a lot about solar flares, because when they do produce a CME, they can be quite strong. So as to where to see them, SDO and SUVI, the 131A, and X-ray flux with GOES. Um, yeah, dynamic vent need a video. I think we probably have some good videos of solar flares. It's like the paparazzi bulb. That's another way of, they're pretty to look at. So
I do have one of
we'll get
the
a good video here.
from May. This is just one of the many CMEs from last May, but I put it in red instead of blue. This is still
Yeah,
AIA 131. And you can even see the CME launch on that, but really I
yeah,
wanted to get the twisting flares and the brightening before the actual flare here.
yeah.
So this is
That's
a good example of a solar flare with a CME. I
yeah.
did not get one without a CME. That would have been a cool contrast to have.
Yeah, I know. Remember, actually, that was kind of funny because it was the Gannon storm. Remember there was that other spot that was in the north that kept
Yes, and in
getting
fact,
X flares with no CMEs, and then
let's
everybody was
see.
mad about it. And then this spot came out of nowhere and just started throwing X flares and CMEs with it.
No, I cut it. So that flare actually had a pretty big flare, or that group had a big flare right before this video too. I started the video and it was really dim, and I'm like, why can't I see very much? And there's a big flare taking effect in the northeast or the
Yeah.
northwest here. So I was like, I'll do a little after it. But yeah, point is, you have some regions that flare and just for pretty shows, and other ones that throw things at you constantly.
What do we call it? Plasma devoid, or I forget. We have a kind of funny,
Oh, there's a term for it. Yeah,
but I forget
Tanya,
what.
help. It was your term, I'm pretty sure.
Plasma
Like,
agnostic.
Yeah, or
no, like
like
depleted.
yeah, for the flares that don't have CMEs with them.
Oh,
You used a
oh,
word that just screams perfect.
we
I
had
know.
so many terms. Yeah,
That's
I
but
per
know. Yeah.
yeah, I mean,
It might pop up in my head here soon.
yeah, we have the flashes. We do have active regions sometimes that keep producing essentially caged flares. So they are very bright, but CME fails to launch. Either there is really nothing to launch, no material that could be, or a magnetic field over that region is preventing CME from launching into space. So they're kind of clickbait regions because when they do flare, everybody is on their
Hype
apps and
reasons.
checking. Yeah,
Yeah.
exactly. And there's nothing.
I love that
So no
clickbait.
CME. Yeah,
Clickbait.
they're like
Click
clickbait regions.
clickbait
But yeah.
regions. Wow. And then Janelle's question, yes, we're in kernel hole season because now kernel holes are becoming more prominent at the edge of solar max. As you're going downhill in the cycle, you have a kernel holes start stretching and opening more, especially towards the center and then the upper regions, and they get quite pretty big. So we are in the period now where the kernel holes are the main players, and they usually can even push active regions or CMEs out of the way,
Yeah, they
which
can
happens
deflect.
pretty frequently. We'll have eventually in last May, no, I did one video. I didn't save this one either, but there was a kernel hole that was rotating, and then a CME occurred from a region, and it actually opened up a kernel hole from the sides there.
Yeah, that's right. We
Pretty
can have
cool.
that was actually October 10th of that eruption. I think it was October
Oh, so
8th
we had
when it
more than.
erupted. Yeah, it kind of pulled coronal hole open. So that was interesting. It
And
was a
then of
coronal
course we have
hole
ones
right
that will
next to
close
it.
them too.
Yeah, we do have active regions that appear from inside the coronal holes too.
What
So
name
they
do we
can
have for
actually close
those?
them. It's
Anyone remember? I knew
anemone,
it started with an A.
yeah, and then
anemone active region.
It's an
They
anemone.
they float
anemone.
up and they just open up like anemone. Oh, CMEs. That's pretty straightforward. So CME is coronal mass ejection, and it's just eruption of solar plasma and launch of it into interplanetary space. It may be launched in our direction if we are lucky or really unlucky, but most of the time it just flies in all different directions. It does not really statistically appear that most CMEs happen on the limbs. It just our geoeffective zone is fairly narrow. And that's why very few of them actually head in our direction, but eventually they do launch in our direction and they may either brush us or really hit us head on. in which case it's really a direct hit and it's very impactful, depending again on the magnetic field that comes with it, which we can't predict ahead of time. The launch mechanism may be different for filaments and CMEs that launch with flares. They are very closely related, but they're not quite the same. CMEs that are former filaments. Filament is essentially a flux rope that's already suspended, that's pre-made, so it's sort of ready to launch, ready to wear a CME. All you need is a trigger to sort of send it flying, and that could be a nearby flare. It
Okay.
could be a coronal hole, but a lot of times it's all the twisting that happens when filaments keep rotating over and over and over again. Some of them do survive several rotations, but eventually they sort of get twisted to the point where they're not stable enough and they just peel off.
Boing.
Um,
It's the noise they
yeah.
make when they break.
They
Boing, boing.
probably do. They probably do make a lot of nice noise. We just can't hear it. But you can see them in quite a few different wavelengths. You can see dimming in some of the wavelengths, and dimming is sort of, at least according to Scott McIntosh's team, it's a small coronal hole that opens up when that CME launches, and you can almost tell from the direction, the way it opens, which way they're going to be flying. If there is a coronal hole that's already next to the CME launch, well, all bets are off because you can have that CME going in a really strange direction. The fast solar wind can deflect CMEs. They don't like to travel over open field lines, so you can get a pretty beat up CME by the time it reaches to us. And sometimes CMEs that are next to coronal holes, particularly near center, they may be looking like they will launch our way, but they're so strongly deflected, all we get is a glancing blow. And that's the season we're in right now. So we have coronal holes, where it's the descending phase of the solar cycle. So expect surprises from CMEs, particularly when launch happens near a coronal hole.
And for those of you that were not around for the May storms, or at least didn't get involved in space weather until afterwards, this is the Glasgow view over a full week as the CME started. So
Yeah.
two, one, two, three, four, five, and then there's a couple bigger ones on the sides
And
here.
that's a radiation storm with that one.
Oh, yeah.
Yeah,
Yeah.
that was the last, that region in the north,
Mhm.
right after, of course, after it rotated around. But there was at least 5 CMEs that were just directed straight square on, head on for us. We're not going to get that kind of luck again, generally. I'd be surprised if we saw something similar to this event in our lifetime.
Oh,
And I'm
don't.
saying that pessimistically so that I'm proven wrong.
Hey, it
Just
it,
to be
uh, it
clear.
it it took 20 years. We could still be around in 20 years.
True. Then again, well, yeah, actually, yeah, I'd say that's pretty accurate because the sunspot, the October storms, was just as persistent with CMEs. Not as many, but
And
bigger ones and harder ones.
and we may be looking at potentially stronger cycles that are coming, but again, we have to wait and see. The solar cycle 24 was on the weaker side, which is why we didn't see really
Yeah.
any major geomagnetic activity with it. Still saw some really nice shows, or at least that's what I'm told. I wasn't chasing back
One
that show.
G4.
Ay, ay,
Isn't that
ay.
crazy though?
Okay.
One G4 and we've already
We're at
had
like 5 now this cycle. I want to say 4 maybe.
so
Historically, though, G4s and G5s used to be more common. So the solar cycle 24 kind of spoiled us for a different reason, because we do have a lot of infrastructure now that's very vulnerable to geomagnetic storming. So they're not looking forward to stronger cycles, which is why I was saying that we can get a CME that works against us as far as impact on infrastructure. Aurora's going to be beautiful, but we
I'm gonna
might,
say if you're
well,
only from the
actually,
Aurora perspective,
and
it's
we might get,
you're not caring.
yeah, and we might get a really nice dark sky to see it. So
yeah. Anyway,
that's what happened in Quebec in
yeah,
1989. They saw a nice aurora with a really dark sky.
yeah,
And that's all 4 of the things that we have for that.
yeah. So now we can go into the Gannon.
Imagery.
Yeah, 'cause
Yay.
Which Mary Beth won't take that.
yeah, I mean, yeah, we can't end this it's the anniversary of this big storm, so we have to, kind of kind of reminisce a little bit about, what happens when we get something good, and it's been 20 years since we got something really good. I love this composite satellite image because it shows just how far south the Aurora Oval was pushed during that. It's like straight over the great Midwestern regions.
I mean, basically central Michigan has got a
Yeah.
corona, it looks like. This is
Yep, like
probably one of the major outbreaks.
so
And
it
I'm
was
right there.
really cool to see that event. And then
Yeah.
of course we
There's
have
our
a couple
photos.
pictures.
Oh,
Mine's on the left up in Minnesota, and then Christian, of course, is on the right from Ohio. And I remember when he posted that picture because we were driving up, and I was like, I think we're going too far north.
Yeah, I had subaraural stuff in the south sky, like on the horizon in the south sky. Ugh, never gonna get that lucky again.
But it was pretty darn cool. And then we have a couple more examples to show because it was just, I don't know, it was a great time. And I'm sure anybody watching the stream probably, for some them, but this might have been their first Aurora show, and that's quite an Aurora show to get for your first one, because then everything after is kind of like, well,
Not as good.
you get some pretty stuff, but it's not, to this degree. And then yeah, that's like coming into what, sunrise, and it's just, yeah, it's just
yeah, this is close to sunrise, so you actually get blue aurora as a result of it. And that was unusual storm in that regard because the neutral atmosphere got heated up and nitrogen migrated to fairly high altitudes. And the sun essentially started to have an impact, and it was glowing like that. So this is related to aurora, but not exactly aurora, because it's basically just molecular nitrogen that's glowing from sunlight, from ultraviolet light. But you
so,
can't really get it with every single show. You have to heat up the
Under
atmosphere,
a lot
and
of right
that's done.
conditions.
Yeah, that's done over hours and hours and hours of storming when you have so much energy that's being put up. So it's not just aurora. All that aurora you see is energy transfer, and it heats up atmosphere and it expands. And that takes that nitrogen molecules up into fairly high up in the sky, where
you
it
know,
finally meets the ultraviolet light just before the sunrise, or
yeah.
you can see it with sunset too. So those are the kind of two things that can happen where you start to see the blue aurora and some of the magentas. And yep, it's pretty cool.
I just love
Specifically, it's the blue get or the nitrogen getting ionized, and then the electric field yanks it up, which is so much cooler than most aurora mechanisms. It's
yeah.
like yoink. Janelle wanted to know too the satellite that this is from because I can't quite
Yeah.
remember the name.
So this is actually composite picture. This is
Different times too, right?
different times. I think they're closely related. There are three polar orbiters, so three satellites that are go around the pole and take pictures in infrared. And what glows in infrared is our cities, first of all, and you can tell how much
Yeah.
glow when
Ugh,
it stops.
look at the
But
eastern half of the
aurora,
US.
yeah, and aurora actually glows in the same ultraviolet light too. So
Okay.
this is where you get a composite image. You basically take several passes and put it all together. And that's why you have sort of discontinuities, because like over Minnesota, for example, I'm pretty sure we were under auroral
Oh
oval and
yeah.
under the intensity. It's just there was no satellite pass that was close enough, which is why you kind of see the gap in intensity there.
What's cool is like, look how I just love seeing how like Alaska is completely north, except for that
Yeah,
little.
oh yeah, you got Alaska completely ignored at this point.
Yeah.
The
Iceland got
oval,
kicked out
yeah.
of the
The oval
auroral
was
oval,
bye-bye.
essentially. Greenland, and when you look at, well, it's
Yeah.
interesting to see because when you look at magnetometers, you could see magnetometers in Greenland that are aligned in west and east lines. They left the chat.
Nothing.
It's like there's
Yeah.
nothing there.
Just like the upper reaches of Scandinavia at that point.
Yeah, it's just
Nothing.
it's a neat, it really puts it in perspective just how strong that was. So it's kind of a cool picture.
I'm just gonna rotate between the photos at this point
Yeah.
now, but that's pretty much it.
So yeah, that's our material for the week. I mean, do we have any more questions to address? Hopefully this helped clear up some things. Um,
Well, we do have an M 1.9 solar flare that just happened.
oh,
Guess where it happened?
on the limb?
Yep, behind the limb. So the same
Yeah.
region that was traveling all across that 4079 actually rotated behind the limb and flared promptly there. Yeah, it's right
Yeah,
there.
I guess the other thing
Okay.
to
Ah,
think too, like another
It
reason
was there.
why we always say like, things always happen on the limb, but what you're also looking at is a foreshortened image. So you have all these longitudes compressed. So it's really not, it may not exactly be on the limb, but it's like, you have all these a wide swath of area that's being compressed that we just don't see. So that's another reason it seems like it's, you know, more happening on the east and west limb. So I figure I'd
still
add that.
stupid.
Still stupid.
Yeah. So I wouldn't be surprised if we might see some CMEs from the same region on the far side, but we shall see. The far side is so far is not looking particularly spectacular. We can probably pull up the map of the far side
Yeah, yeah, I might as
from the
well
solar
here.
orbiter. Yeah, might as well go through, although it's not particularly exciting. And for current events, yeah, we probably had solar sector boundary crossings. If there was a structure, no, would I will know what to say about it because would it
Oh,
be
that little bit of,
probably
yeah.
probably not, but can't completely rule it out. But strange things happen at the solar sector. So, okay, I am ready to share. So Solar Orbiter is now monitoring the far side, and it does have a few regions to watch, but there's nothing particularly huge at this point.
I was gonna say I can see no complexity in that even without a magnetogram.
Yeah,
I
they
can
look
pull up the
pretty,
magnetogram
yeah,
too, but
they look pretty
it's not
uniform.
looking, yeah, it's not looking
Yep.
very impressive. And as far as flaring activity, there really hasn't been a whole lot. The last most significant flare was about M 2.8 that happened on May 6th. So it's been quiet, but that's where we at. We
So,
have to,
Nor
yeah, our best bet is still coronal holes.
yippee.
No.
I know everybody's like, oh, the other thing was that was funny was it had to be careful, like, because people on the internet love to compare things, and you really can't compare events. You can't compare sunspot regions. You can't like
can't
that
compare
last one
KP
that we had
levels.
when the people were comparing it to the May sunspot regions. Like, no, you can't. Don't do that. Don't.
Oh yeah, regions to that too. No, God,
Yeah,
no. I've seen
like
some pretty decent CMEs from C-class flares that were kind of small sunspots, and I've seen advanced twisted sunspots do nothing.
yeah. It's
Nothing. The sunspots themselves only give probability of likelihood of eruption, nothing more.
It's kind of like what Tamitha always says, like if you've seen one solar flare, you've seen
I've
one
seen
solar
one
flare.
solar flare.
It's just no, it's like what you, I know as humans we're designed, like we want to look for patterns. That's just what we do. But it seems like like with this kind of stuff, as soon as you try to put a pattern to it, it does something that breaks that whole thing. So you really can't. You see one
Yeah,
event, an
our
event.
current flare risk system is really based on statistical performance of sunspots, well, active regions, and it doesn't, we really don't have a good way of predicting when flaring will happen and whether or not that flaring will be eruptive. There is research done, obviously, in this area because we want to know when flaring is about to happen.
We
So
do.
far, we just have statistical likelihood of flaring, which is a flare risk, not even the probability, it's a risk that something might happen. So there is a risk of 5%. It could happen, but does it mean that it's going to happen? Possibly. Will it be eruptive? We don't know. there's definitely work, and it looks like there is some promising research looking at what happens in active regions. It does require a fair amount of monitoring with AI involvement, but we shall see.
Yeah.
We shall see. So far, it's far from operational, and the biggest predictor of eruptive solar flare, X flare in particular, is if the region had eruptive X flare prior to that. So history of region help, but again, it's not everything, particularly with filaments, because if there is a flare that happens nearby and that filament is not stable enough, it's going to launch. So it's going to look like a minor CME, a minor flare launch a CME, but it's a lot of conditions that had to be met. And it doesn't happen every single time. So complex system, a lot of things we don't understand right now. It's definitely being studied, but in every complex system, a lot of events need to happen for the outcome we want. And yeah, we have to wait. We have to wait and see.
Wait and see. But yeah, it's I mean, we have a lot of infrastructure that is susceptible to stuff, so there is definitely research being done in this world. So that's the one good thing for us Aurora chasers is like there is a vested interest in wanting to understand and know, and hopefully, someday be able to predict this stuff, but we're pretty far from that. So this
Yeah.
is where we're at. And I think that's about it here. That's here. Solar max vary quite a bit from cycle to cycle. What
Yeah,
about
solar minimum can really
yeah.
be pretty sad. And I think solar minimum around solar cycle 24 was actually
Okay, well,
not that great because solar wind was really slow and not a lot of things were happening. But could you get a CME launch during solar minimum? Yeah, you can.
Mhm.
It's not as common.
Was
It's
was solar,
rare.
was solar cycle 24 the one that had where the solar wind was so slow that they thought it like disappeared?
no,
Yep.
I don't think that was that one.
I forgot what cycle that was, but it was like, yeah, they were like, this
It
something
did
something bad
go
is happening.
down pretty dramatically. Like I think I saw 200 kilometers a second, but it never
Yeah,
actually
it
disappeared.
was like really slow.
I'm gonna, while we have at least a quick second, I'm gonna bring up 211 during 2007,
Okay,
or well,
do it.
oh crap, would that have? No, we had SDO then. Fine, I'll use 2008. But basically, I wanted to show the differences in what the sun looks like between active sun and
Or minimum.
not active sun.
That's fair.
But apparently, how far back?
Yeah, so actually the one good thing is we're already seeing it. Like the coronal holes that we're getting now have been producing faster solar wind too, than last cycle. Like we've already seen them clip 800, which is pretty
I
good.
only saw maybe once or twice for cycle 24.
So that's
Okay, here
that's
we
a
go.
positive thing.
Although it's, yeah, taking longer than I was hoping it would.
Do.
Well, maybe it's just sitting here loading, so maybe not. But the idea is the Corona looks entirely different beast. It doesn't have all the bright areas. It's just dark patches, occasional bright points popping up here and there. There we go. Actually, no, that's still better than what it needs to be. 2018. Yeah, so this was the almost end of cycle 24. So, or almost the beginning of 25.
Oh yeah, look at
So this is our empty sun. And it's
that.
not the emptiest it gets either, because you got three active regions, it looks like. I wonder why it won't go back any further than that. Let's try January. Not that it's that important, but the idea is minimum is minimum. There's zero sunspots generally. You might get lucky and see a tiny one or a plage, but they're not going to do anything eruption wise. You still do have occasionally a filament maybe launch, but usually not. Kernel holes still, but
Quiet. Tis quiet.
no, it's not going to look. All right, that's fine.
Yeah. I guess the point is, yes, they can be variable. So, all right, let's see. Do we have anything else? Okay.
Yeah, so big question from Janelle. What
Yeah.
exactly causes 11-year cycle?
Too
That
big.
is,
We can't go over that right now.
yeah.
That's an
That
entire
is,
thesis that people are still doing, really.
Yeah, it's
it,
I mean it's really the what do they call it? It's the
the solar dynamo,
yes, and it's
It's a
the
but
the rotation.
it's a combination of the alpha and the omega effect, at least as of now, the current trending research, but you've got differential rotation that twists a vertical, let's say, technically poloidal field into a toroidal field, which allows then that field, that's what you get with sunspots. And then there is differential, well, there's the convection inside of the photosphere, which twists that field back up. And that whole time period takes about 11 years. When it's the most twisted, we get max. And when it's completely not twisted up, we get minimum. That's just the textbook definitions of things in a quick summary of it now.
What do you
Lots to go off of that, though. There's probably quite a bit not accurate, but
but
that's just
essentially I
current
guess if you
research.
want to break it down further, it's the differential rotation that causes it all. Like it's the and then the fact that you hit the it's the is it the poles that rotate slower than the
That's
middle?
differential rotation.
Yeah.
So you get 40
So
some days for the poles and about 28 days for the equator.
yeah, so actually the 27-day cycle of the sun rotating is the average basically of that. But you have it rotates quicker in the middle versus
It's really not a huge difference for the sunspot range too. It's from like 0 to 30 degrees. The actual difference in time is not too large. The dramatic part is after 40, 50 degrees. When you get up higher there's a cosine of theta you go through, which after you hit about 60 degrees gets higher and higher, faster and faster.
was that the 55? Remember Scott was like
Actually, good point. Yeah,
the
kind of.
55 mark, 55 degrees north or
yeah,
south.
so, yeah. But basically, what we are trying to say in many different words, this is a field of heliophysics that has a lot of different theories and at least several models why sun shifts magnetic poles over 11 years have been proposed. So it's hotly debated as far as what's driving it and how exactly it happens, but it's something that sun does on a regular basis, and the strength of how rapid that change is and what we see in terms of sunspots and geomagnetic activity depends on many different factors. But we probably should plug in Dr. Scott McIntosh coming on
Yeah.
in a couple of
Oh
weeks,
yeah.
actually. And he will be talking about solar cycle and solar cycles because there's probably more than one.
And the Forbes article.
Yes, and the
And
fourth article.
yeah, Forbes Space Weather Prediction Center strikes again. I swear it's something else. They probably give us more topics than we
Yeah.
want, but
Because yeah, we
yeah,
were
this
going to cover
was
it here, but then we're like, no, we have Scott. He's the perfect one to cover that. So
yep.
yeah, we'll
He's
have him tackle that wonderful
Yeah,
article
but
that came
when it
out.
comes to space weather, do not go to Forbes as your source of trusted space weather news. Even though they did cite the actual research, the way they twisted it is very misleading. So just because cycles might be stronger does not necessarily equal that we're going to see aurora for 50 years every single day. We
Yeah, that was
Right.
a
still,
very stupid headline.
yeah, unfortunately. But yeah, it's pure clickbait and mis misuse of fairly decent research.
Yeah, so that will
Accurate.
be covered. Fear
That
not.
will be covered.
But on
So
that note, I think that's everything we got today. We've actually been going on for quite some time,
I was gonna
so
say, yeah,
you
our
yeah,
know,
rant day.
so thanks to everybody for hanging on, as we get good. Because this is what happens all the time. We just get chit-chatting and, as questions come in. So, but we'll let you guys have your time back for the day and happy Mother's Day to everybody out there. We tend to do these things on holidays, which is really funny. Probably because it's on a Sunday. It's always on a Sunday
It
usually.
is always on a Sunday. That's a good point.
Yeah. Well, that it seems to work out for us and, you know, whatever it is. But yeah, we'll be back. Actually, next week is our guest, right? Elizabeth, I think. If I'm getting the dates right.
yes.
I don't
Elizabeth
even,
Butler is who
yes.
is a space weather forecaster is coming on next week. And if you have questions about SWIPSI products, particularly the forecasting or any type of model related to Aurora, send us your questions. We will make sure that they do
I
appear
think
on
they
the
get
stream.
answered.
But she will be covering Swipsy stuff. And then, yeah, we have Scott McIntosh. So our May is pretty packed.
Yeah, it'll be fun.
Yay!
Be fun, yay! So then maybe we'll get something fun to talk about, but it doesn't look like it. So it's good to have
Yeah,
guests.
current activities for now.
Yeah,
So
there
until we get
isn't.
some info or something fun to do.
Indeed. All right, let's see. Yeah. So anyway, we will let you guys have your evening back. So again, thanks for tuning in, and as always, we appreciate you being here, and we love doing this. So it's been fun.
All
So
right.
until next week.
Same
Adios.
bat time, same bat channel.
Yes.